Welcome to Algebra 1, Unit 8, Lesson 7-3, Solving Systems of Equations by Elimination. Pearson Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objectives today are I will be able to solve systems of equations by elimination, and I will be able to analyze special types of systems. We saw in a previous lesson, Lesson 7-2 from Unit 8, that we can solve a system of equations with the substitution method. In Lesson 7-1 of Unit 8, we learned that we could solve a system of equations by graphing. Here's the third way to solve a system of equations, and that's by the elimination method. Anytime we're solving a system of equations, the special types are where you end up with two lines that are the same line, which gives you infinitely many solutions and is consistent and dependent. The other special system of equations is when the lines end up being parallel, which means there is no solution, and we call that mathematically inconsistent. So we're going to solve some systems today, as we have been, but we're going to use the elimination method. You use the addition and subtraction properties of equality to solve a system by the elimination method. When you are trying to use the elimination method, you want to try to eliminate one of the two terms. In this example, we have 5x minus 6y is equal to negative 32, and we have 3x plus 6y is equal to 48. What you want to notice about these equations is there are three terms. There's an x term, a y term, and a constant term. And as I said just a moment ago, the goal is to try to eliminate one of the terms, either the x terms or the y terms. To do that, you have to have either the x term or the y term have the same coefficient. In this example, the y terms each have a coefficient of 6. You also want to notice their signs. They are opposite signs, and when they are opposite signs, we're going to use the addition property of equality, which means we're going to add the two equations together. So to solve this example, we're going to add the two equations together. The reason we are adding is because of these signs here in front of the 6y's, in front of the y terms. One's negative and one's positive. They are opposite signs, so when they're opposite signs, we add. So we add them together term by term. 5x plus 3x is equal to 8x. Now notice how I did that. One thing I mentioned to my students when I'm working with them individually is, even me, a math teacher of 13 years, I read the problem so I don't make a mistake. To add the x terms together, it's 5x plus 3x. And I'll even, working on paper, touch my pencil down there. 5x plus 3x is equal to 8x. When we get to the y terms, negative 6y plus a positive 6y is 0. Therefore, those terms are eliminated, and that gives us the name, the elimination method. I bring down the equal sign, and I have to add the constant terms together. Negative 32 plus 48, well, we actually end up subtracting those two things, and that gives us 16. Negative 32 plus a positive 48 gives a positive 16. Now we have a very simple equation to solve. 8x is equal to 16, and we solve that by dividing each side by 8, and that gives us x is equal to 2. So now that we have the x value, we have to plug the x value back into one of the two original equations and then solve for y. And it doesn't matter which of the equations you use. I'll just use the first equation, which is 3x. I'll do that work up here. 3x plus 6y is equal to 48. Remember, I'm substituting this 2 in to this equation for x. So when I substitute it in, it gives 3 times 2 plus 6y is equal to 48. I simplify this here. 3 times 2 is 6. Bring down the plus 6y is equal to 48. Subtract 6 from each side. The 6's on the left eliminate. They become 0, leaving us 6y is equal to 42. And I divide each side by 6, which gives y is equal to 7. So now we have our x part and our y part to our ordered pair. Therefore, the solution of this equation is the ordered pair 2 comma 7. Remember, ordered pairs always come x comma y. That's how we plot a point in the coordinate plane. So what this means is that these two equations have one solution, the point where they would cross, or the point where they do cross, and it will make both of these equations true. Example 1t, we're going to look at another example here where we're going to use addition to solve using elimination. One thing I stress to my students is to copy down the original equations, even if it's on a worksheet, rewrite them so you can have the original equations and refer to them if you need to. So here I'll just copy down the two equations. And since we're trying to use elimination, I want to look at the x terms and the y terms to determine if they have the same coefficient. And if you look at the x terms, they have the same coefficient and they have different signs, or they have opposite signs, which means we're going to add the two equations together. Something I didn't mention in the first example I worked out was that this is the proper way to write this when you're adding the two equations together, is to put the plus sign on the left and put parentheses around the second equation. Then we have to add them term by term. And in this equation, we're eliminating the x terms first. 2x plus negative 2x is 0. Those two are eliminated. And then we add 3y plus 9y, and that gives 12y. Bring down the equal sign. And then finally, 11 plus 1, that gives 12. Then we solve this equation, which is a very simple equation to solve. And we solve it by dividing each side by 12. 12y divided by 12 leaves us 1y equal to, and 12 divided by 12 is 1. So we have the first part of our answer. We have the y coordinate. Now we need to go back and substitute into one of the original equations, which we'll write down, and I'll just use the first one. Remember, you can use either one if you want. We have to substitute this 1 in for the y this time, not for the x. So when we substitute in, that'll give 2x plus 3 times 1 is equal to 11. We simplify this equation by multiplying 3 times 1. So the new equation is 2x plus 3 is equal to 11. A lot of students don't even write this step right here. They substitute in and do the multiplication mentally. 3 times 1 and gives 3, and they just write this equation down. Now it's a two-step equation to solve for x. I'll subtract 3 from each side. The 3's on the left becomes 0, leaving us 2x is equal to 8. And then I'll divide each side by 2. Giving you x is equal to 4. So the ordered pair, that's our solution, is 4 comma 1. And I remind you, or reiterate, that ordered pairs come x value, then y value. As I was grading some papers, I noticed a lot of students were putting it backwards. They were putting y comma x. It's always x comma y for an ordered pair. Example 3t, multiplying one equation. Well, if you look at this equation, it's these two equations, 3x plus 6y is equal to a negative 6, and negative 5x minus 2y is equal to negative 14. If you look at the x terms, the numbers are not the same. We have a 3 and a 5. If we look at the y terms, the coefficients are not the same. We have 6 and 2. So we can't use the technique right away that I just taught you. What we're first going to have to do is decide which equation we're going to multiply by a factor so that we do have the same coefficients. Again, I copy down my original equations, and when I go through this little process, and this is a very quick process, mentally it is, especially if you know your basic multiplication tables, what I think to myself is there a number I can multiply 3 by to get 5? And there's no easy number. There is a fractional or decimal number, but there's no easy number that we can multiply 3 by to get 5. and vice versa. There's no easy number that we can multiply 5 by to get 3. Looking at the y terms, we could multiply 6 by 1/3 to give us a 2, but a lot of students think in terms of whole numbers, and there's no whole number that we can multiply 6 by to get 2. But if we think about it the other way, we can multiply 2 by 3 to get 6. So I'm going to multiply this second equation by 3, and you're going to see what happens. First, I'm just going to copy down the first equation to keep myself straight. So that would be 3x plus 6y is equal to negative 6. Now on this line, I'm going to write the result of multiplying the second equation by 3. 3 times negative 5x is negative 15x. Negative 3 times minus 2y is minus 6y. And 3 times negative 14 is negative 42. So now when I look at these equations, after multiplying the second equation by 3, you can notice that the y terms each have a 6 in front. And they have different signs, which means we're going to add the two equations together to solve. So I'll add the two equations together, and I'll do that term by term. 3x plus a negative 15x is negative 12x. Negative or positive 6y plus a negative 6y, they eliminate, bring down the equal sign, and negative 6 plus a negative 42 is negative 48. And again, I want to stress what I'm doing here when I say that or when I do these calculations. I go negative 6 plus negative 42. A lot of students will end up subtracting here 42 take away 6 to give 36 and put it down as a negative 36. That's not accurate. It's a negative 48. We solved this one-step equation by dividing each side by a negative 12. On the left-hand side, the negative 12s divide out, leaving us 1x. And on the right-hand side, negative 48 divided by negative 12 is 4. So in this case, we've solved for x first, just like we did in our very first example. Now we choose one of the original equations to substitute 4 back into. Just work with the first equation because there's no negatives in it. And I always write it down. 3x plus 6y is equal to a negative 6. Substituting 4 in for x, that gives 3 times 4 plus 6y is equal to negative 6. Now, I had a student ask me the other day, how come this isn't 34? Well, it's not 34 because this is one way we've defined multiplication. A number next to a variable or a coefficient in a variable together implies multiplication. So this means 3 times x. So this is 3 times 4, which simplifies to 12. Write down the plus 6y is equal to a negative 6. We continue to solve this equation by subtracting 12 from each side. 12 minus 12 on the left goes away because it becomes 0. Leaves us with 6y on the left. And then on the right, negative 6 take away 12 is negative 18. Dividing each side by 6 gives y being equal to negative 18 divided by 6, which is negative 3. So we have both components to our solution. The x part is 4, and the y part is negative 3. So these two lines, if graphed, would cross at the point 4, negative 3. Example 5t, our final example. The title of this example is multiplying both equations. We're still solving using substitution. The title of this example implies that we're going to end up multiplying both of the original equations by a number so that we can use, and this shouldn't say substitution, this should say elimination. It should say elimination. So I'll copy the original examples down, or the original system down, so I can do some work on them. 3x plus 5y is equal to 10, and 5x plus 7y is equal to 10. And looking at these terms, the x and the y terms, the x terms, as we did in the previous example 3t, if thinking about it, there's no number we can multiply 3 by to get 5, and vice versa. There's no easy number to multiply 5 by to get 3. For the y terms, it works the same way. There's no number really that easy number we can multiply 5 by to get 7, and the reverse of that is true. There's no easy number to multiply 7 by to get 5. So what we're going to do is multiply both equations by a number to make either the x or the y terms have the same coefficient. One easy way to do this is to multiply the first equation by the coefficient of the x of the second equation. The coefficient of the x in the second equation, or the number in front of the x in the second equation, is 5. So we'll multiply the first equation by 5. Since the coefficient of the x, or the number in front of the x, for the first equation is 3, we'll multiply the second equation by 3, which will give us 15. So when we multiply the first equation by 5, that'll give us 15x plus 25y is equal to 50. And multiplying the second equation by 3, 3 times 5x is 15x, 3 times 7y is 21y, and 3 times 10 is 30. Now, as we saw in the previous two examples, we have terms, and in this case, the x terms, that have the same coefficient. They both have a coefficient of 15. Now, this is the first time we've seen where the equations have the same sign. In this case, the 15s are both positive. So instead of adding the two equations together, we have to subtract. When the terms you're trying to eliminate have the same sign on their coefficient, you subtract. The way I shorten this down in my classes, same side, subtract. When you're solving systems by elimination and the terms have the same sign, you subtract. That's 3 words that begin with S. Same side, subtract. So that's kind of a way to remember what to do when you're using the elimination method. So subtracting these term by term, 15x, take away 15x, becomes 0, therefore they're eliminated. Subtracting the y terms, 25y, take away 21y gives 4y, bring down the equal sign, and subtracting the constant terms, 50, take away 30 gives 20. Now I solve this equation by dividing each side by 4. So y is equal to 5. We have to take that result and substitute it into one of the original equations, either the first equation or the second equation. It doesn't matter. As long as you do your work correctly, you'll get the same answer. So I'll just use the second equation. I think I've used the first equation a couple times in this video lesson. So I'll use 5x plus 7y is equal to 10. Remember, I'm substituting 5 in for y. When I substitute 5 in for y, it gives us 5x plus 7 times 5 equal 10. I simplify the equation by multiplying 7 times 5, which gives 35, equals to 10. Now I use the subtraction property of equality and subtract 35 from each side. The 35s cancel each other out on the left, leaving us 5x is equal to, simplifying 10, take away 35, that gives a negative 25. And then I divide each side by 5 to give x is equal to a negative 5. So our solution is x is negative 5 and y is positive 5. Remember, when you're solving systems of equation with elimination, you want to look for the variable terms that have the same coefficient. If they don't, you can always multiply one or both of the equations by a factor to create a new system of equations that have the coefficients the same on either the x or the y terms. This has been Mr. Pilarski. Thanks for watching. Bye-bye.